Okay, it is October 20th, Thursday, October 20th, 2022. Let's get ready for a great night. I hope you all had a great week so far. I hope you're excited to do some live coding. That's what we're going to do tonight here on stream. So we're going to stay focused. We're not going to get too crazy here, and we're going to have fun together. If you're there in the chat, let me know. That would be great. I'm going to test. Hey, okay, now you can hear me. I was having a little audio issues before, but we will figure this out. We'll go with it, okay? So here's the deal, everyone. We are going to dive into some data exploration. So we created a data set on a stream not too long ago where we actually pulled down all the flight data from a public database. Hey, good to see you, Yusuf. Hey, Data Basics, what's up? Time to cause some problems on purpose, that's for sure. So I'm going to go into here and I'm going to activate my Kaggle 2 Conda environment, and I'm going to go ahead and start up a Jupyter Lab environment, and we're going to start coding in Jupyter. So we created, I actually think I finished the creation of this data set while I was offline, but this data set consists of all the flight data from the federal transit agency, I want to say. So let's go over to my data sets. Let's go over to my work. And I'll even show it to you all here. This flight status prediction data set, I will paste into the chat. So if you're watching this afterwards, you should be able to see the link in the chat, or I'll link it down low. Hello, everyone in the chat. Hope you're doing well. Check out that data set. So I did not include column descriptions, but I did start a very early EDA notebook, and we're going to dive more into this data outside of a Kaggle kernel. So let's do it locally on my machine so we don't have to deal with any slowness. Not that Kaggle is slow. Actually, I've heard that today that Kaggle, or maybe it was yesterday, they upgraded their online instances to become faster. But that's news for another day that we can test out. Tonight, we are just going to dive into this data. So let's go here. Let's go into our flight data. And yeah, this is the flight data that we have. So we are just going to start an flight data EDA session. Let me know if you have any suggestions what you want to see us look at specifically. Let's remember where this data set came from. It should be in the data description that I wrote. That's right. This website, transitstatsbts.gov. I don't know what the BTS stands for, but they have all these data sets with all the information for flights in the United States. Going back to 2018, that's what we're going to look at. Flight data exploration. So we're going to use Pandas and Python, of course. I'm coding here in a Jupyter notebook and Jupyter Lab. Thank you for your lives. Learn a lot from them. Oh, glad you learned a lot. I appreciate it. I've been told that I need to focus better. So I'm trying to take that constructive criticism and focus more today. Question in the chat about if I went to school for data science. I did. I got a master's degree in data science. All right, so these are just the standard imports that I typically import when we're doing data exploration. There can be more, but this is going to be these are going to be the main ones for now. So we're going to import pandas, numpy, and we're going to import matplotlib, pyplot as plt. We are also going to import seaborn as SNS. Let's do style sheet of, let's let's use matplotlib style sheets. Style sheets are nice with matplotlib because you can kind of keep a standard style to all your plots in your report, but you can do something a little bit more than just the plain Jane. Bureau of Transportation Statistics. That's correct, Michael Mallinger. But we can do something cool. Like, what do you guys think about Seaborn V0? Oh, these are new ones. I haven't used these before. So I'm thinking this could be a good color palette. Seaborn -V008 dark grid. Let's see if this works. Seaborn. I've never used these versions before. V0_8 dark grid. Of course, that doesn't work. Let's see what styles are available. So these are the ones I actually have on this machine. It might be that it's a newer version of matplotlib that has these newer versions. So let's see what this error message said actually. Not found in this library, value URL path, C style available. So maybe if I upgraded matplotlib, these would be in there. But let's just use Seaborn Dark. Let's see what that looks like. Dark palette. Let's try that. Oops. I didn't copy correctly. We're going to paste this down here. And then we're going to load an extension lab black. What lab black does, it auto formats our code for us using the black formatter. We might want to import some other things later, but this is probably good enough to get started. So I like to ls our flight data, or whatever data we're working in. So let's just do -ls flights-flights. I think this is where I put all my data. So let's do ls-l. I actually like to do this gflash. So this will tell us the file sizes in readable format and list them all out. So I made these Parquet versions. That's what we're going to use. So let's just do a grep on Parquet to see only the Parquet files. So you can see that they are just a few megabytes, 200 megabytes each. We could, of course, use the CSV version. I think we will want to load in this airlines.csv to map some of the names to the actual airlines. But yeah, oh, someone says, Yusuf says, I've been waiting for your live to start in France. It's 3 a.m. there. Oh, you're staying up late for me. Thanks for hanging out late tonight. This is fun. We're going to look at some flight data. All right, so we have the Parquet file. We have the CSV file. No reason to really load these CSVs. Now, take note of this. The CSV versions are almost 2 gigabytes each. The Parquet versions are 200 megabytes. Think about the compression that's found in this difference. And a lot of it's probably due to the fact that you have a lot of sparse data, a lot of repetitive data, but maybe we can get things loaded a little faster too by doing some tricky things. Greetings from Peru. Jaime says, welcome. Chess player LOL streams in chess category, but I ain't complaining. Oh, my stream is in the chess category? Oh, I need to switch over. That is important to know. Oh, just a little side story here. I had set my my stream to chess because on Monday I played a grandmaster in chess, and guess what the outcome was? I played a grandmaster in chess, and this is a little side note. No, I'm not going to go too far into this, but I played this grandmaster in a simul, so he was playing 20 games at once, and my game got a draw. So I feel amazing the fact that I drawed against a grandmaster, but I think he was going easy on me. If I'm completely honest, I don't think he was legit trying against me. I think he was trying to draw as many games as he could early. So, but I mean, I was losing. I looked it up, and I was probably. We got a kaleidoscope guy in chat. Welcome. How's it going? Okay, so we're looking at this data combined flights. We have one file per year. That's how I set this up. And there's a lot of interesting things we can do with this data. So I read in the Parquet version. And if we just do an .info on it, we can see all the columns that we have and the file types that they are. So I think I was looking at this before, and I will pull this over here on the other screen. And I had noted some columns in this data that I think might be interesting. So obviously we have the flight date, when it occurred, the airline. I think it's going to be interesting. Where it came from, origin and destination. Then these are the real interesting ones: cancels and diverted. So I think there's a lot of columns here that we don't necessarily care about, like DOT ID operating airline, IATA code operating airline. There's just like a lot of granular detail that we might not necessarily care about. Hey, we have someone in chat from Colombia. Welcome all the people who are hanging out here, and thanks for the cheers and stuff. So let's filter this down. Now there's something pretty cool we can do if we only care about this subset for now of data. Oh, another thing we might want to do is look at this data and get an idea of the memory use that it's taking up. So it is 2.6 gigabytes plus of memory use. So that's closer, if we remember, to it's more than, because it's even more than just the CSV version of this, but it's closer to the CSV version in size than the compressed Parquet version. So on this machine, I have plenty of memory to work with, but if you're working in a cloud environment, we might not want to read in all of these columns. What does 20 at once mean? Just side by side or with time limit? I'm not sure what that comment means. Oh, it is a simul. Yeah, he played them everyone at once. So he was just walking in a circle, making one move per person. This guy, the guy I played chess against, has the world record at once. This guy. Timur. If you want to look him up, this is a guy that I drew in a chess game. But not really. I'm telling you, he just let me. All right, so nice thing about Parquet files is that we can actually, when we read in the Parquet file, we can provide it just the columns that we care about reading. Now see, with read CSV, we don't have columns as an option, I believe. But with Parquet we do. So with columns equals this column subset, now we have our data frame from 2018, only the columns that we really care about. So I filtered down here, like, where is it from? Where is it to? Was it canceled? Was it diverted? And then the main thing we're going to calculate off this data is we have our departure time. This is the CRS departure time. So this is the departure time that it was expected to depart. And then we have the actual departure time. The difference between this these two should in some ways be the delay in minutes. Unless it looks like unless the flight actually departs early, which it looked like it did in this situation, then it would show a delay of 0. But if the departure time is later than it's expected to, this delay would be a lot longer. Someone's saying Akash is saying they upgraded Kaggle GPUs. That's awesome. I need to give it a try. Let me see this link. Yeah, I did see them post about this. This looks, wow. You can get 2 T4s. So dual GPUs. Do you get charged double for it? Like, does it count double towards your time? I'm guessing not. The RAM going from 16 to 30 gigabytes will be pretty awesome. Okay, so Origin Airport. Yeah, so delay in minutes. We can look at that a little bit closer. Next. We already pulled in this first parquet file. Actually, let's from glob, import glob, and just get a list of our, I'm going to restart this kernel and get a list of the parquet files. I have this weird flights folder, and then I'm going to do star.parquet to get a list of all our parquet files. And then we can just load in like the first one and call it data frame. Now a few things. Can we make this more efficient? Let's look at the info on this. And we see that some of these are probably not the most efficient types that they could be. And we're going to fix that next. Let me just check something here. Why does it say my... All right, this is just messed up. Okay. So we have the airline. I think so. The thing is, when you have things like airlines where these are each string values, but if we do a value counts on this, it's actually just a limited number of airlines. So what we can do is as type. And let's look at the DF info first. So this is a smaller version. It's only 500 megabytes. But we can change this to a categorical type, and I think it'll save us some space. What else can we change? We can change, I mean, really, if we just do cat calls and we do airline, origin, destination, how many unique ones are the origin and unique will tell us the number of unique origins there are. Only 397 out of, yeah, over 500,000. So that would definitely benefit from being a categorical variable. Destination would. Origin state. Destination state. It's a little weird that I'm pulling in the origin state or the destination city and not the origin city. So let's also pull in the origin city. origin city may not be in there. So let's just drop all the, I spelled that right? Okay. City names aren't a big deal because we have the state. So out of all of these that we have, hello, is the data set coming from Kaggle? It's one that we created and put on Kaggle. So you can check this link. That I had put out earlier. Yeah, there you go. Someone else helped me out. Thanks for the help out. All right, so let's take each column and let's cast them as a categorical variable. So we will go and do this. And again, I think we had 500 plus before. Now 311 megabytes. So it's going to be a little bit faster when we're messing around with this date. Also, let's look at flight date. I think this is good to keep the flight date like that. All right. So I think what we want to do now that it's not really that big in memory to do this, we are going to pull in each of the files for F in Parquet files. We are going to append a list with this, with reading each file. So what this will do is all of our Parquet files, which we ran glob to find, 2018 to 2022, all of these will be read one at a time, and they will be appended to this list, and then we'll make PD concat these data frames. Let's reset the index and let's drop it. And we probably could delete this DFS afterwards, but let's go ahead and leave it like that. And then what the other thing it's going to do, so this is read in and format data. Jigaman, how's it going? Welcome to chat. Now if we do a df info on this, we have a subset of categories, columns that we pulled in. We can go out and get more if we want later. It's good to start with. 1.5 gigabytes in memory. So we're saving a lot of space. We'll be able to move around with this fairly quickly. Now the next thing I want to do is to think about, I might have origin city name. I missed a comma in the import columns list. Oh, that was it. All right. Actually, let's do, I kind of want to remember all the, maybe do like another pass through of all the column names. And now that the data is small enough, remember if there's any other columns that I might want to actually include. So here in my data description, I actually put each of the columns and the description. It's a little weird, funky with this format, but we can kind of decipher what these mean. So flight number, I don't think maybe flight number would be interesting because flight number, I think, is the same thing that's used to describe the flight each day of the, or each week over and over. So we could find like which flights are often delayed. So let's look at this first one. Make a temp. Oh yeah, the other thing I want to do here is PD set option max columns, display dot max columns. Make this something like 500, so it's big. You guys have seen me do this before. So now we can see more of these columns when we're displaying them. So if I look at this flight number marketing airline. I think it has underscores here, and that's why it's... There we go. And we do a value counts on this. Okay, so this one flight 1095, is the most common flight. And let's just query where the flight number marketing airline, which is a really long name, equals this, and see what the actual airline name is. So let's Google this. Frontier Airlines and 1095. It must be this flight from Orlando, Islip to Orlando? What's ISP? Anyone? Any ideas? Hey, thanks for the bits, by the way. Islip. Am I crazy here? What's Islip? We'll figure it out. Someone in chat's got to know. So this is the most common flight, apparently. In our data set, it's happened 23. You think it's not New York. Oh, Long Island. That makes sense. That makes sense. So flying from New York to Orlando, these are all the people trying to get out of the cold in the wintertime. It's the most popular flight, or most frequent flight. And I guess, I don't know much about flight numbers, but is a flight number unique from the route, like the to and from location, if that's unique for Frontier Airlines? So they might have 20 of those flights per day, but I don't think so, because you could have, like, you wouldn't want people to get confused with their flight number in the same day. So it has to be unique per day, maybe day a week. Anyways, all that's to say, I am convinced that the flight number is interesting enough for us to include in our list that we want to import in. So I'm adding it to my list. I'm adding a comma too. What else is here? Originally scheduled airline. So that means if it like changed airlines. That seems like a flight, another flight number operating airline. Operating and marketing. So I think what might happen is they'll market a flight, they'll sell you a ticket, it being a certain airline, and then they'll like shuffle you off to a different airline. So that's why we have a lot of these saying flight number and operating and marketing. So we're just going to ignore the operating one. All right, so here's all the origin information. We have the city name. So let's pull in the city name just because it'll be a lot of repetitive ones. But look, Chicago's the most common city. So we're going to add this to the list. This is like the origin code. There's a world area code. That's okay. Destination city name. We can do something like the worst city to fly out of in America. Something like that, based on delays. That would be kind of fun to do, right? It's not unique across airlines. 1095 many airlines. What do you think is Dallas? The most... You think Dallas is on there? No, when we did origin airline, just to double check, let's see what the top do. Value counts on origin state. California is the state with the most. let's just assume origin and destination have similar numbers of flights in and out. Origin city name is, oh yeah, that has nothing because we haven't loaded in. But Dallas is third on the list. Newark. I think Newark would have to share a lot of its stuff with New York. I don't know though. Okay. Now we have this departure delay indicator. 15 minutes or more equals yes. Departure delay groups. I want to calculate these on our own. Wheels off time. That might be interesting because then we would know when the flight, because I've had this happen before where you're on a flight, you get on the flight, so it departs the gate, and then you just sit on the runway. So how would we calculate that? It would be like wheels off time. I guess that would be the taxi out time. Taxi out time and taxi in time. Yeah, so let's pull those in. Let's pull those taxi times. Taxi, I believe, is the time spent in between the gate and when you're in the air. Taxi in. We already pulled in. Oh, this is the arrival time. Okay, so we can do something with, if we look at this data, we can look at not only was the flight delayed from when it was supposed to take off, but was it delayed in the air? Delays are very weather dependent. Some are much better at handling weather conditions. Are way better than, okay. That makes sense. It's kind of like cities. Like, we're not used to a lot of snow where I'm from. So if someone from Michigan came and saw how we respond in a snowstorm, they would laugh at us. Arrival delay in minutes. That's interesting. It's basically the difference between these again, but I want to see like if the time of day has a. Now this whole diverted stuff, there's a lot of data in here about the flights being diverted, but what I noticed was it's so rare. Like if we look at DF temp, diverted, the mean value, so that's gonna be the amount of times that a flight is actually diverted. It's 0.1% of the time a flight is diverted. So we could look at all this, like I think it was here, diverted airtime, diverted wheels on, all this other stuff down here, the diverted tail number, like it could be diverted to 5 different airports. We are not going to look at because it's just so rare that it happens, and let's just say it's outside the scope of this analysis. This could be interesting. Carrier delay versus. Oh, but I don't have this in here. Versus weather delay. What I did was I dropped some of the columns that were just almost exclusively null values, and I think these were some of them. So let's just keep it with this. You guys feel good? Prom asks how long we've been streaming. Not too long, like half an hour. So we're just at the point where we're loading in this data. We're picking the columns to read in from our airline flight data. Let's delete this. I'm going to delete some of these columns. Just so you know, if you escape out of your cell when you're working in a Jupyter lab, you hit the escape key and you press J and K. You can jump around, and then it's like Vim key bindings. So if you do something like I want to delete the cell. I'll type DD on it and it's gone. Poof. All right, so now we have our data frame, and if we do an info on this, we probably could make some of these categorical, like destination, state, or city name could be categorical, but I think we're good. We're still, now we've jumped up to 3 gigs though. So it's a decent size data set. All right, the first thing I want to do here is put these delay times into groupings. Because this is like the big one. When the flight is delayed, that's what people care about. Let's put this in single dashes so it looks like that. And let's take this data frame and let's do departure delay in minutes and do our handy trusty histogram with 50 bins. Okay, what do we see here? So we could title this too. Distribution of flight delays. So this is a very long tail, and most of the flights are not delayed, or their delays are very, very low. So there's also, this probably would be more of a normal distribution if we calculated the difference between departure time and estimated departure time. But because anything that's early, that actually took off early, is considered not a delay, then it's kind of truncated at 0. So let's actually query this. Since it's so hard to see what's going on, let's query when this departure delay minutes is less than 30, maybe. Seems like a good place to start. Still here, we see most of them are 0 with this long tail of delays. So as much as we complain about flights being delayed, it seems like there aren't that many delays. Okay, stream's over. We're done. No, just kidding. I think I might have too many bins here. Let's just do like 20 bins. Because I think what's happening here is this delay minutes. If we do a value counts on this, value counts. Yeah, it's only rounded to the nearest minute. So it's not like sub minutes. So if we're doing less than or equal to 30 minutes, we probably should do 30 bins. That'll make it 1 bin per the minute delay. Okay, so there is like a small tail going out here. But most of them are not delays. So this is like less than 30 minutes. All right, now the next thing I want to do, I guess we could plot this same thing, but when it's not equal to 0, so just exclude all the on-time ones. Oh, it's still really low. So if we do not equals to 0, I'm surprised by that. So it must be the biggest delay is just 1 minute. Where does this start to... So if we just say greater than 5 minutes, greater than... I want to get to a point where we can start seeing what's going on here. Greater than 20, it's still really hard to see. Greater than 30. It just becomes less and less likely the further over you go. And then... Coding with Strangers, how's it going, man? Good to see you. Hope you're doing well. Should it be greater than 30? Yeah, so I'm trying to see, like, if we just cap off this stuff to the left and look everything to the right. well, what we probably need to do here is do a range. So this between that and let's say 60 minutes. There we go. That's what I've been looking for. Where have you been all my life? So let's do greater than 1 minute and less than 60 and make this bins like less than 61. So this is a very clean distribution. When you remove all the flights that are on time, then it kind of like is a very clear pattern to the amount of delay time that you get. So this is when people start getting pissed, like when there's 30 minutes delayed. I guess it depends who you are. But it is like less and less likely the further you get out in your delay time from occurring. Yeah. Now, another way to look at it, and this might be just a big waste of time, is if we go to the CRS departure time. One thing is this might be a little bit weird when we have flights that take off around midnight, because then I think it'll go to 0 or it'll start over at 1. So then, right? So we have this CRS departure time and then the departure time. Now, the thing is, the departure time for a canceled flight, do you notice how this column is a float, but the CRS departure time is an integer? That's because there's always a expected departure time, but our actual departure time might be nothing if the flight is canceled. But if we just naively took this and we said departure time minus CRS departure time, in theory, for this first one, it should be a delay. Oh no, so this one left 47 minutes early, is that right? Let's compare this to our departure delay in minutes. Because I think these times, let's double check these times. Yeah, it's in local time, hours, and minutes. Wow, yeah, so these flights left early. And these were really late. So 378. So why is this 378? Oh, okay. So we can't just do a simple subtraction. Trying to think how we would do this if this occurs at midnight. We might accidentally say that this delay is way longer than it is. But all right, let's try to parse this. So if we're just dumb about it, right? And then we take the first two values. Ooh, it really didn't like that. Really did not like that. Can I do this? Departure time round 2. Round -2. No, because that's going to round it. All right, let's look at this. Python convert. I don't know why this is so zoomed in. What we want to do is take a clock like this. We have nothing to split on. Wow, this seems like a very complicated way to solve it. So this is another way to do it. Question, what is as type? Just convert the type, right? Yeah, so what I was trying to do, if we take the head on this, like of the first 5, the thing is, if we make this as type string, it changes it from a float to a string. And then we could do string of the first 2 values, which gives us these 18s, right? And then we could do 2 to 4, which gets us the minutes. But it was acting really slow, I think because it doesn't like Ask GitHub Copilot. That's funny. What I think it is it doesn't like the fact that these are floating values. So what does it do? Let's find when this is NA. Departure time is NA. And then let's try to do this. That's, I think, where it's going to freak out, because it's going to convert it to nan, the value nan. So I could do drop NA subset departure time, right? And then try to run this as type string 2 on that. And this would be like our departure hour. Because what we want to do is take the hour and divide it by 60 and then add it to the minutes. Hey, what am I doing? We're looking at this flight data set. It's pulled from a government list of all the flights that take off and their times and stuff. You know what? I think this is a rabbit hole I don't want to go down. The main thing I wanted to show here, and this doesn't accurately show it, but let's... Knowing that this is incorrect because we didn't actually account for the hours and minutes. Yeah, I think if we plotted this with more bins, what we would see is more of a normal distribution around 0. There's a lot of weird things going on here. Like, I don't know how a flight could take off this much early. Well, whatever. But we're good. All right, the next thing we're going to look at is grouping of delays. So I did look this up, and it looks like there's a Wikipedia page on flight cancellations. Of course there's a Wikipedia page on it. There's a Wikipedia page for everything. Hey, David J. What software am I using? Do exclamation point YouTube. Oh, wait, just go to my YouTube channel and check out my introduction to Pandas in Python. Also check out my introduction to Jupyter Lab. And I'm using Pandas, the package, and I'm coding in Python. Okay, so we have flight delays. People have done this analysis. We're not the only ones to do it. Maybe we could try to recreate some of these. Average type of delay, largely. The main thing I want to focus in on is they have these types. I found this earlier. So there's these types. Okay, it's here. This sentence. Delays are divided into 3 categories, namely on time or small delay. So that's up to 15 minutes. Because, like, who cares? 15 minutes delay. If you're going to freak out about a 15-minute delay, come on. Medium delay, that's when you're like, kind of mad, but I don't want to say anything. Let's be honest. I would never like be mad or yell at him, but about a flight delay. But large delay is 45 minutes or more. So keeping this in mind, per Wikipedia, which kind of means it's like facts because we trust Wiki. Let's create these delay groups. So if we have our delay, departure delay minutes. Yusuf says I had to redo one of my videos. Oh, nice. You redid one of my videos with a different data set. That's what it's intended for. My tagline, my motto of my YouTube channel is to inspire creativity in data science. So I want you to be inspired to do something interesting with your own data, because you can watch hundreds of YouTube tutorials and not do anything yourself. But the goal is that we get you in a place where you feel comfortable doing these things yourself. Hey, someone's greeting from Mexico. Welcome, Victor. How's it going? All right, so we have departure delay in minutes. Most of them are 0, 1, 2, 3, 4. Okay, so we already saw that in our previous analysis. So let's do if it equals 0, let's add a new column called delay group. Then let's locate when that delay group is 0 on time or early. Sorry, I'm doing this wrong. When this is 0, then our delay group will equal this, on time or early. We're also going to make our other 3 groups. Small delay. Let's not add a slash here. That's not. So this is small delay. This will be medium delay. And this will be large delay. These are the official categories, people. So this is going to be when our delay is under a certain condition, which we will add here. Hold on one second. Yeah, so this is when our delay is, why did this add a parentheses in here? I want to do it outside of this. So when it's greater than 0 and it's less than or equal to 15, that's going to be our small delay. Then greater than 15, less than or equal to 45, medium delay. Greater than 45, boom. We don't even need this and statement because that is a large delay. Let's let this run. Hey, we got some people in chat. Simbisa, can I assign values using loc? You can assign values using loc. Yeah, so what this is doing is locating and then assigning this column name or this column values for only when these conditions are true to these values. This is a much faster way of doing it than to like write a function and go over it that way. There might be even faster way of doing than than this, but this is nice. So now if we go into delay group, first let's check if any of them are null. Just a quick is NA and sum. So when are these NA? Ah, so these are NA when there is no departure time, I think. Yeah, the departure time is null. And that's probably because it's canceled. So let's do another one. If canceled equals, if true, that's just the Pythonic way of saying it. So if it's canceled, then the delay group is canceled. And now let's look and see, isn't a sum. We're trying to get this to nothing because there should be nothing that, I mean, out of, now we're at the point where out of 29 million flights, only 1,000 of them have an NA value, but I want to figure out why. This was not canceled. It was not diverted. And this should just be, these all look like they departed on time. Or close to it. This is really weird. Can we do a diff on this? Diff axis 1. So we're kind of dealing with the final few, but it looks like 11,000 of these should just be zeros. Then we have a few other funky ones. Let's just not deal with it because it's weird that they're not in there. What kind of flight data are we collecting? We've pulled this flight data from geez. I will paste this here. If in the future if someone asks, you can tell them that's where it is, or this data set. And someone else says, hello, I'm loving the stream so far. I know this is a little off topic, but how far are you with Plotly? I'm starting frequently and I have loved it so far. We're going to do some Plotly Express stuff for sure. We did Plotly Express last stream too. Plotly fluff. I just said that weird. All right, so let's do value counts on this. And let's plot this. We're going to pull our color palette. There we go. And let's give this a title. (2018 and 2022). These are your flight results. So should we do these as like a percentage? If it's on time, small, delay, medium, large, and then canceled, is actually pretty rare that a flight would be canceled. You're saying floats? Not sure what that means. So this equals 0, but we looked and we saw they were null. That's off. My flights get canceled all the time. Maybe you're flying out of the wrong airports. Okay, so looks like this is the main result. Let's look up as a percentage. So the way we could do this as a percentage, because this value on the x-axis is kind of, hard to do much with. We can do this value counts, and then we can sum and we can divide by the total number of flights. Get something going here. Need some good background music. So if we do this times divided by d of shape 0, it should give us a rough percentage. So this says 2% of flights are canceled. What percent of US flights are canceled? Did it just autocomplete to... Okay, so they have their numbers per year, 3.2. It looks like 2020 was crazy, but what we're seeing of like the 1.5. Okay, so maybe what we can do here is... We could group by year. We have to make a year column, I think. Flight date. Year. Pull out the year from this. So this will be our year. So the question we're trying to answer here is, what is the percent of flight results by year? So we want to see... They're showing like a big shift, obviously, when COVID hit, that a lot of flights were canceled. But before, and then also in 2021, it looks like less were canceled. Maybe because people were traveling less or they had less. But this will be interesting to see. So let's group by year. Then we'll take our... Also like putting a show here. Our delay group. And then do a value counts here. And we're going to make like an aggregation data frame. I also like to unstack these. That's how I do it. What unstacking does is it puts it in this type of format where we have... Like it's hard to actually see visually how the years compare. Let's call this dfag. It's just a temporary data frame name. It's a really small data frame. And we'll mess around with some style sheets. So we can do background gradients. And I think it depends a little bit on, my theme here. But background gradients can be really helpful. Let's look at some Pandas style examples. So it's this table visualization stuff where you can do a lot of stuff with Pandas. You can really get in there with your styling, colors, and I don't know why it actually doesn't render well in these examples they're showing. But we're showing things like background gradients. Let's see if there's like a way of doing... Yeah, so I think we could do CMap as like greens. And then it would be greens, or we could do reds. I kind of like greens right now. So what this really shows is the raw numbers, but not the percentage. Is unstacking like unpivoting? Yeah, it's very similar to pivoting. Because what we have here when we do this group by year and then the value counts on delay group is we have like a multi-index. So if we look at this index, the index is a multi-index with the year and then each of these subgroups. By unstacking, we basically flip this multi-index so that one of the index is columns, one of the index is rows. Hope that makes sense. Really cool stuff we're doing here, guys. All right, but I'm not too happy with this because the aggregation is not in percentages and we want to see percentages. So let's do a sum axis equals 1. Now we have the total number of flights and we could have done this a lot easier. Let's maybe do how many flights per year. We could just do a bar plot with data is, no, let's just do this. DF year value counts sort index plot kind equals bar fig size like a 10.5 and then title is flights scheduled flights per year. We're gonna see some weird stuff with COVID, right? Let's also add, yeah, these numbers are so big it makes it look weird. It would be nice just to add the number to this, but that might take too long. The big thing to note, do we have all the months from 2018? Why is 2018 so? Something's weird with 2018. I just want to see. It does start on January 1st and it ends December 31st. So I'm not quite sure what happened in 2018 to 2019. Maybe this doesn't include all airlines every year. Because there's no real, like, do flights really go up that much in 1 year? It's like almost went down to what happened in 2020 and no one was traveling then. So something funky's going on here. But the main thing I wanted to do was to do this sum and then take our DF aggregation. And can we just divide this to get some percentages? No. We could just take like canceled and divide that by the sum. Now that gives us a percentage. This might be like a weird way to do it, but we can loop over each column and divide it by this aggregation. Let's do this up here. So what am I doing here? I'm just looping through each column and I'm dividing that column by the total amount for that year to get percentages here. Now I could also just take this DF ag and multiply it by 100 to get it like in round percentages. I don't know. Don't even need to do this in the data frame. I could just do this right here. Now we have the percentages. Wait, 99% has a small delay. Something's weird there. Oh, I see what I'm doing. I'm aggregating each time. And I don't want to be doing that. That's going to mess up my total calculation. But this should be better, guys. All right, let's see what see. Is this table visualizations file style feature new with Pandas 1.5? Embarrassed to say I haven't updated since 1.3. Funky Monkey, you should watch my video on newbie Pandas mistakes. I think this has been around a while. I think it's been around, just people don't know about it. It was changed in version 1.4. So yeah, if you're using 1.3, maybe that's why. Oh my gosh, you can use value counts normalize equals true. Okay, so let's, mine would be blown if that's what we could do. So you're telling me everything that we did with this could just be done by doing normalize equals true. Mattias. Oh, I put it in here, not in value counts. Sorry. How would that work? Normalize? Oh, man. That's awesome. Thank you for telling me that. Thank you for telling me that. Look at this. All this dumb code that I wrote up here is not necessary. And I'm going to use that all the time. See, you can learn stuff all the time. That's what's so great about working in a field like this. And that's what's so great about streaming to you all, where you teach me things. Thanks, Mattias. I'll buy you a beer next time we hang out. Can we do this with count plot? Would it be easier? Oops, that's not what I meant to do. Seaborn count plot. Yes, we could. Yeah, so I don't know why I tend to use like the built-in Pandas plots more often, just because it doesn't involve using a different package. But count plots are nice. I mean, I do use, when I want to see like the standard deviation of something, I could do a, so let's do this exact same plot up here, for instance. Count plot with our data is going to be, so how would we do the count plot? Oh, we can just only give it X. X is going to be DF year. Yeah, so it adds a little bit more color, more flair, more pizzazz. How you look for hidden patterns in the data? What model of neural networks? Ah, you're getting ahead of yourself. We're not really doing neural network stuff right now. Can I explain what normalize does again? Okay, so we wrote a bunch of code. Let's make sure normalize does what I think it does. Yeah, it does. Okay, so what normalize does here is when we do a value counts of like year, it'll give us the raw numbers. So 2019 had this many flights. 2021 had this many flights, blah, blah, blah. What normalize does is it gives us the percent of the total. So now we see 2019 is actually 27% of all the flights in our data set. Memo says something about sklearn pipelines. Yes, I do find them clunky too. I don't use them as much as I should. I'd also like to order these columns in a way that makes sense to me. Shall we? So on time early, small delay should be first, then medium delay. And there may be a way that I could have set this up using like an ordered categorical type. But this makes more sense that it's first on time, then it's a small delay. Hey, what do we got here on Twitch? Stain Train subscribed with Prime. Stain Train, thank you so much. I appreciate the subscription on Prime. I got to spin the wheel. There's no getting around it. I spin this wheel anytime we get a new subscriber on Twitch. You can use Amazon Prime to subscribe on Twitch. If you have an Amazon account, it's free. Doesn't auto renew. Oh, I wish it didn't. Just want to respin it. Let's not do a basic. My thoughts on Java, I'm not a big fan, but I also just don't know enough about it. 10 push-ups, okay. Thanks again for the Prime Stain Train. Also, all the new followers, thanks for hanging out tonight. Okay, so yeah, this order makes more sense to me. So look at this big flip in 2020. But these are not normalized values. So let's rerun these cells. Why isn't this working? I thought we had our... Well, first of all, I think I see what the issue is. I'm multiplying by... Hey, Clipped. Thanks for this subscription for 6 months. 6 months, Clipped. Appreciate it. Yes, you're right, guys. I'm multiplying by 100 twice, which makes 0 sense. Let's spin that wheel. Some of these are kind of crazy. I'd have to go get a whole banana and eat it. 10 push-ups. Next month I don't have to spin for you. I can't get out of it that easily. All right, so here we go. Craziness happening in 2020 where you actually had more on time than you did in previous years, but you have many more that are canceled. Now let's see how this lines up with what we Googled. Why is this only January through May? Is that like peak travel time? What's up, MGX? Welcome to the chat. So they are saying, Swang Lord, thanks for the subscription. Let's spin the wheel. So I think we can't compare this apples to apples, but we are seeing this big jump in cancelizations. Not as high as 11%, but maybe because we're not looking at January to May, which makes sense. 10 push-ups again. I'm going to have to lower that one. If you're watching this later on YouTube, you guys can fast forward. Hello, awesome screen name. Thank you, VW Wishy. So percentages don't line up. Should we see what the source is of this? More than 1 in 5 domestic flights was delayed in early 2022. So this is why they board your flight so early, because they really don't want to be delayed. That's probably a number, like even if they're 1 minute delayed, it would probably appear on this. But why did they say January through May? Can anyone explain that to me? All right, let's just keep on going with our analysis. Other people can critique our analysis later. We're going to do our stuff now. I'm going to get another crack comment. I know. So let's look at it by month. Let's do the same thing by month. So what we'd have to do is basically the same thing. This is a nice thing about doing this in code. We can just reuse. This should be by month. And let's go ahead and make this a different color so it stands out. There we go. Okay, so what do we see here with months? Typically, and this might be why they were looking January through May. Typically, all the cancellations happen early in the year. Could that be because everyone's traveling? Well, people travel during the holidays. So I would think it would be high here. But, it's probably weather related? I don't know. Need someone here to tell me. Okay, so let's keep on trucking around. You think this is due to winter storms? Like, could be. That's getting into like April. April's not that bad. On which days of the week and in which months were the more aircraft accidents and flight cancellation with summer hot weather days more often cancellation due to weather? Okay. This could be COVID cancellations. That could be it. This could all be because of COVID hitting here. So all these flights were not they were still on the books and then they had to cancel them. Let's test that hypothesis. Why high cancellations in January through, let's just say in March, April? What does it look like by year for these months? So let's do this. Let's go back to doing this by year, but let's query where month is less than or equal to 4 or greater than or equal to 3. And let's maybe make this oranges. That's my favorite now. Every time it's a business question. Oh, it's COVID. Yeah, but you have to prove it. All right, looky here. Looky here. Our hypothesis is justified or is shown to be correct. When we group everything together here and we look at the highest cancellation month, this is over almost 5 years, 4.5 years of data. We might be led to believe if we just aggregate by year, oh, this is the high time for cancellations, but it's not necessarily. It was just really messed up because of COVID. So if we do this same plot as above, but we do query year not equals 2020, even though 2021 was kind of messed up by it, but let's see what this looks like. When are the cancellations? So the cancellations are all coming in January and February. That's when all the cancellations are due to weather, I would think. It looks like we kind of have two peaks in cancellations. Like it gets higher in the winter for winter storms. And then it also gets higher in the summer, probably for thunderstorms. I think it would be nice to group by month and year and see April. Yeah, so how could we see month and year? I know what we could do. This is a pretty cool. I've used a few packages that do this. This is one of them. So let's see if I have this installed. Plot using CalMap. It's not installed, so I'll go to my terminal. Conda activate kaggle 2. Pip install CalMap. Not pip install CalMap. There we go. What this will let us do, if it installs correctly, which it did, let's plot this example. I said plot this example. Okay, so this is an example plot. There, that looks a little bit prettier. Now what I'm plotting here is just fake data. Every time I run it, it's fake data. But let's try to make this. What do you guys think? We can make one of these calendars for each year. Would that be cool? Can I get my OBS back up? In the group by past month and year. Yeah, but then we're doing this unstacking. Like, okay, true. I could do it this way. I could do group by month, year, and I could just query the canceled, right? And then I could do a size on this and unstack, right? And then I could do like style background gradient. And you could see where it ends in 2022. Our data ends, but yeah, this is, you can do as type int, might make this look a little prettier. No, it's because of these nan values that doesn't like it. But yeah, I want to see Make it for next year? I wish. Put it in a banana and call it Bananada. Are you sure the color gradient correct? The large values in the early on time column seem similar color to the smaller values in the rest of the heat map. I see what you're saying. Oh, that's a good point. Okay, so I didn't mention this, but the background gradient can be applied to an axis. So I probably should do this in a different cell so it doesn't have to compute this. So if we do axis equals 1, it'll just show us the value across the year. So on time early is always going to be the highest when we do axis equals 1. I believe by default the axis is 0. So it's showing the darkest value across years. I don't know. It might be a linear scale, but it's by column. It's coloring by column. So like if you were in Excel, you could color it by column. I think we do. Yeah, we can do axis is none. If we do axis is none, then it basically treats all columns. It like makes a gradient scale based on all the values. Hopefully this makes sense. The main point is that I think that axis 0 makes the most sense for this use case because we're trying to see out of all the years, what was the worst year or the year that had the most percentage on time early or the most percentage canceled. Otherwise, these small numbers kind of get lost in the fray, but I mean, to each their own. I want to do this cal map. I know you guys aren't super excited about it, but I don't care. So it looks like what we do is we just need to get an index with the date time. So that's going to be easy. Group by. What we'll do is we'll group by flight date. And then we'll do at canceled. And we'll take the mean of that. What that'll do is give us the percent of canceled flights on that day. We could do this by airport too. We got to look at airports and we got to look at airlines. Like we're just so much more we need to do here. Okay, so if you're enjoying this in chat, just like give me an F or something. Type something in chat. Bump it with the F if you think this is interesting. Okay, so this gives us our events. Thank you all. Thank you all. Twitch chat is greater than other chat. Just kidding. Okay, there comes YouTube. Okay, so key error is wrong because year equals 2015. Oh yeah, because I don't have 2015. 2018. Oh, okay. So look, it's dominated. People are loving the stream. I love it. Thanks, guys. You saw my TikTok today. Nice. Trying to get on TikTok with all you little kiddos. So can we do like a... We don't want this to be a linear gradient. We want this to be like... Oh, I do like them. Let's look a little bit more at what the things we can pass this like... Can we do it on the logarithm? Yeah, we can do this matplotlib normalize. That'll normalize the values. monthly border. I think that kind of looks cool. True. I think the darkest heat should be on cancellation as the most severe. Found your channel recently, really helpful and very inspiring. Thank you, Meat. Say hi. Socrates. Hi. Your plot? What? Yeah. But this is... So basically what we have here is this. If we plot this as a histogram, we have these big outliers that are really... So usually if you take a log, yeah, so if we take a log transform of this, it makes it more of a normal distribution. These are one of the tricks that us data scientists use from time to time. Because you have these like big outliers that otherwise make it not look so great. So let's try to do this. There we go. But now the downside is that they all look so similar. Let's also make this a multiple axes of 5 by 1. For I year in, we have 2018. I know I shouldn't be typing these out, but just want to make sure I get the range right. For that, in enumerate, what this will do is let us run for each year. There we go. Whoa. Whoa. And let's add title. Set title as year. And then we need a fig subtitle. Cancellations. US flight cancellations. And what happens here is the Y needs to be, it's always up too high, like 9, and then font size, maybe 20. All right. So what do you guys think about this? I think it's pretty cool, huh? What's the difference between something like Jupyter and Notebook and IDE like Spider or PyCharm? Check out I have a whole video on that. Check it out. Axis I for the title. Oh, yeah. I didn't. Good catch. And that's probably why I could make that subtitle so low. Maybe make the C map. Let's pick a different color map. Something like this. I think this is pretty cool, guys. Yeah, this looks cool. This looks cool. It looks like a sunny day. Do I like Jupyter more than VS Code? I've tried to do Jupyter in VS Code, and I just don't. It doesn't feel right. It doesn't feel right. I use VS Code. I do code in VS Code a good bit. Show you. This is some of the stuff we were doing on our last stream. Usually it's like exploratory stuff in a notebook. Then if you have any code you want to factorize, you write it in an actual IDE environment, and then you import it into your notebook next time. Now we can make that interactive. Yeah, we probably could. So speaking of Plotly Express, someone mentioned this up earlier. Heatmap calendar. They might have. This apparently is like a cal plot. No, this is what we just... Oh, Plotly cal plot. Huh. All right, let's try to install that. Pip install Plotly cal plot. Please don't have a lot of dependencies. Oh yeah, you're changing my NumPy version. Okay. So we are going to do events. Let's reset this index. So this will be events with our X as flight date and our Y being canceled. There we go, folks. I probably should do this log scale again. Modern technology. Look at this. Now we can actually hover over them. Someone just mentioned it, and what, in 10 seconds we had it up? So that's pretty impressive. How long does it take Kaggle to transfer money to my local bank account? I think it depends. Probably which country you're in too. Sometimes pip is awesome, other times not. Yeah, mostly awesome. So it is cool that you could see. Okay, so let's keep in mind that we just don't have data from here. So don't let that bias our view. But it's like, wow, look at all the cancellations with COVID. The big hit. And then also 2020, these cancellations were kind of... Oh, sorry. This is 2021. I think this is when there were like strikes with pilots. And if we look at the values, I don't think they're normalized by year. So this really dark here is 238. And this not so dark one is like oh, these are negative values. Yeah, that's that weird scaling. But this is cool. Okay, let's... Maybe second COVID wave in 2021. Yeah, I think that's what it was. Okay, so... So my viewpoint on interactive plots sometimes is that they're more trouble than they're worth. You can even annotate Plotly figure layout with certain positions, explaining if you want. Yeah, there's a lot you can do with Plotly. It's getting better and better each time. Rocklebest, welcome to the chat. Is there a reason to seasonally adjust the data? I don't know. I don't like the seasonally adjusted stuff at first. But what was I saying before that? I was saying that, hey, Rye, thanks for subscribing with Prime. 8 months. 8 months. We got to spin the wheel for Rye. What I was saying is I think sometimes interactive plots are like, if it's on a website, it's needed, or if like people want to dive in and see these actual numbers, but this can be put in this top one can be put in a PowerPoint or something pretty easily, even though I think the Plotly one's actually pretty beautiful. So let's go and see what the spin landed on. Push-ups incoming, he says. Okay, we got a gambler. 10-second hamstring stretch. Just what I needed. Okay, hopefully this stream is fun for you all. Now I want to start looking at airlines. That's the thing about delivering these kind of messages to managers. They want clearly about the information. So all the results might not be the most interesting. Only the biggest results are the most impactful. True. That's true. Tech guy, Dylan, this is all just, so you mentioning that seasons are weird because of where you are. That's true, but keep in mind, this is only US flights that we're looking at. So let's compare airlines. Who has the most delays? Who has the most cancellations? All right, so first let's just get an idea of the airlines that we have. So we could do SNS count plot for DF with our X airlines. Airline. This is kind of hard to see. So this might want to be our Y. I like using horizontal bar plots when the names are so otherwise harder to read because you have to turn your head otherwise. So one thing I hate about Seaborn's default plots too is this weird color palette that it defaults to. So let's just do palette is blues or something. At least it's now the same. And now how do we sort this? Order. See, I wish I could do just ascending, but I think what order wants is a list. So what order wants is, and this is kind of why I don't like using this, is DF airline. Now I have to do it here. Value counts. And then I could do the index of this. And then make this to a list. Airlines ordered. And then if I do order here, yeah, now it at least looks like that, but now the color palette is weird. Let's do color pal 2. So that's the second color in my color palette. Now we're getting down to interesting. Who's the most reliable, i.e. on time? That's a good one. On time. So that's like neither canceled nor delayed. Or early, yeah. Okay, so Southwest, Delta, SkyWest, we have some big players. I kind of feel like maybe we should focus on the big players. I pulled the Heatmap shirt for the stream. Yeah, it's a perfect shirt for this. It's the Kaggle one. They gave me this one. Use colorblind palette to be inclusive. We could do that. We could switch the Seaborn colorblind. I actually like the colors on the colorblind. I work with someone who's colorblind in it. I mean, I think the shades are nice. Now I need to recreate my color pal. There we go. And then where did I create it later in this notebook? Oh, I just called it pal before. All right. So what do you guys... What is the horizontal axis here? So the horizontal is the count of flights. So let's add a title here. Number of flights in data set. Oh, that's the other thing is I don't think this will let me do that. So I'll need to set title like this. Okay. The cancellations get skewed, or am I wrong? So what do you mean? These cancellations is because we have a bunch of nulls? So do you guys think it's good to look at... Wait, so Southwest has 5 flights in the data set? No. So this is IE6. So that's to raise to the power of 6. Yeah, how do we make this look better? We could do x set x label flights and make this million. But then how do we make this count plot? See, this is where I get messed up using Seaborn, because like I know how I could do this and actually get this IE6 to be removed if I just did like the value counts. So this is why I find myself not using a count plot very much. Like what exactly did Seaborn give me that I couldn't have made on my own? So yeah, let's just take this count plot out. And then we'll do color is pal 2, maybe. Ascending is false, is true. And then I also like doing this. Width is like 1. And edge color is black. Yeah, that looks kind of sweet, right? And then I could do this, right? These value counts and divide it by 1 million. Let's do 100,000. Put this in here. Wrap this in this. Now, this makes a little bit more sense. It's the 50 So this is 5 million flights for Southwest Airlines. That looks good. You like it? We could even take it up a notch and add the numbers in here, but I don't think we need to do that yet. Let's get to answering some of our questions here. What I want to do is so let's say a minimum threshold of at least 2 million flights. So sorry if you don't have 2 million flights. No, let's say 1 million. Let's say 1 million. If you don't have 1 million flights, you're not going to be looked at in our analysis. Let's see where airline equals. Hate how the categorical does this. So this is top airlines. These are all of our airlines with 1 million. Flights at least. And we're going to look at only the rows where these airlines are part of. Jose, simple answer, you need to learn Python. You're asking which language to learn Python. Can I use Google Colab? Yes. Yeah, so be honest, fool. We're going to get to that. We're going to do things in percentages. So the first thing we can do, we're going to call this df top. We're going to reset the index and drop it. We're going to copy this. So we're actually creating a copy of this data frame. And this is going to be like our subset of only the big airlines. Then we're going to group, we're going to do the same thing. Group by airline, flight, we might be able to answer all these questions in one plot. Delay group. Value counts. Now we know about normalize equals true. And then we're going to unstack this. Data dude, we're looking at someone send him the link. Ooh, something went wrong. I think it's because we have some NA valued delay groups. Yeah. I may need to reset index after the group by. My inkling was it was this. Oh, but it isn't that. So you're saying... Oh, so what I do need to do here is group by both of these. I think. That's where I was going wrong. It's kind of fun to work with a data set that's this size, where it's like middle of the road. Oh my goodness. As I say that, like my machine is 50 gigs of space. Geez. 50 gigs of memory we're using right now. Some of that's OBS. I'm just trying to get the size. I'm trying to get the counts. I'm trying to get the counts of what the delay group is by airline. Maybe I need to stop this. And let's see how much memory we're using now. I'm going to start from scratch just to make sure that I free up this memory. Okay, we're down to 10 gigs now. It's much better. I think the size function will work. Yeah, yeah, you're right. All right, so starting this over, there's a lot of this we don't need to do again. I think that we're making a lot of slices and copies of the data frame, which is where we're getting into trouble. Like this top airlines thing. Probably could have been a better way to do that, but yeah, so now we're at 20 gigs of being used. Do you need such a powerful machine to work on a large data set, or is it an advantage of the memory you have? It definitely makes everything easier if you can fit your stuff into memory. Just makes life easier. If not, you have to start using things that tend to complicate things. So getting a EC2 instance that's huge can save you a lot of time in trying to develop something that will actually work with like Dask or whatever. Do you run your projects locally? Yes, I am right now. That's what we're doing. Not at work, but here I do. Hey, we got, I think this is the biggest streaming crowd I've ever streamed to. On YouTube, we have like 125 people. This is insane. So I hope you guys are enjoying this. I guess this is a sign to me that I need to be less of a jumping all over the place and just kind of focus on one project. All right, so I think the problem is trying to run this group by airline and delay group. So you're saying I just need a size here. That's my problem, right? That was my problem. When should we use PySpark over Pandas? Very, very large data sets. Very, very, very large data sets. If you can fit it into memory. Just do that. Why? Oh. So this is one of the things that we didn't consider. When we make this airline column into a category, and then we start to do things like plotting or grouping by, it assumes that there is a category of this. So can I fix this just by recasting this as a category? Like as type string, as type category. So maybe like this. And then like this, unstack. There we go. Now we have just the top categories. And we can't do normalize in here. I don't think so. So this is where we run it. So doing the value counts will not work here. Can I do it this way? DF top group by airline, delay group, value counts, like this. Is that going to go crazy again? And then unstack this. This gives us the same result. So this is what I was trying to do before, but now we can use normalize. I think this is going to be good. All right, so now what I want to do with this, I also want to order it in our order that we set up here. And then I want to do a stacked area plot. There we go. Maybe now it says smaller value counts will work. I think the reason why value counts wasn't working before was because I had these categorical variables that did not exist. That's my suspicion, because the size of the data hasn't changed, or the memory sizes, but our use of the memory has gone down. But I still think the root cause is something different. Okay, so let's make this kind of like the last plot, the last big plot that we'll do. But it's going to be spectacular. So I'm just going to make an aggregation one so we don't have to recalculate this each time. And then we could plot it like this again and then do fig x. Let's make it bigger. Oh yeah, big size. And then this will be here. Let's take this legend and put this outside the plot here. A little bit too tall, I think. There we go. Do you guys see what we're doing here? Everyone see what we're doing here? Because I group by both airlines. Rob, why did you give... someone says, Rob, why did they give you data where everything is wrong, spiked due to COVID? What to clean all the years when there were flight restrictions? Alps, it's not wrong. It is what happened. It's life. COVID happened. We can't pretend like it didn't. So clean. What is clean? What is... Like, what if every 2 years we have something... I mean, we kind of do. There's always like a recession or something coming around the corner. So nothing is ever clean. And this is why time series forecasting is so rough. Because... I remember I was meeting with like an executive or some people in a call center, and they were saying, yeah, our models are almost working well, but we just need to get past the time where the recession hit. So then we'll have a bunch of clean data that we can model off of. And and my response was, yeah, until the next recession hits. And sure enough, that was like 6 months before COVID. So not a dumb question, but honest question. And I appreciate you asking it, but I just want to make sure that, like we realize that with real life comes real messy data. All right. So on time and early. Here's the thing. The cancellation, I don't think we can really glean much out of it because it's so skinny here. It might need to be its own plot, but I would like to sort this maybe by the on time. Now that we're like this ordering is, I think, in just in alphabetical order. Let's sort it by the on time early. So that bar is the largest. Or sorry, goes ascending to descending. Okay. So maybe something like this. That width 10 wasn't a good idea. 0.8 edge color. Let's do that again. Like this. Maybe we could add percentages boxes to these. Data Dude just asked if we ever messed with background gradient. Dude, check this out. Background gradient. Background gradient. Background gradient. All right, this is our plot. Can we... We want to add the values in our stacked bar plot. We would like it to be kind of like this. The thing is, when we get to these small percentages, it's going to be really hard to see. So this is like the double-edged sword of stacked plots. Is your eye can usually tell the difference between the first variable pretty well. So that's just like a bar plot. But then trying to tell the difference between the next ones can be tough. So let's maybe split this out. By the way, let's just show here. The most on time, Republic Airlines. The least on time, Southwest. JetBlue is pretty bad for its size too. JetBlue is, remember, one of the smaller airlines, and yet they have a good amount of delays, even small delays. And I guess if what you really care about is those medium, large, and canceled, because who cares about a small delay? If we really care about these, what's down here, then JetBlue is the worst, in my opinion. Even though I do kind of like the stuff that JetBlue gives you when you fly. A stream graph would look good for that data. Yeah, that would be cool. I think these, by the way, I think this plot is really cool. Let's go to Twitter. Made this plot on stream tonight with 100 plus viewers. Was a lot of fun working with airline data. And then I should link to my YouTube. copy this link. Make sure it works. Aren't you guys so happy you're here for me posting this? MMA, like the fighters? What are you guys talking about? Okay, so the only last thing I want to do maybe is we could make 1, 2, 3, 4, 5. Actually, what we want to do is change these groups. So take df top, flight status. No, what was it called that we made? Delay group. And let's just make 2 groups. Let's make 2 groups. We're going to make a mapping. Delay mapping. Okay. Yeah, I guess we could do it this way. We're going to map each of these to different groups, which is, if it's on time or early, that's okay. Small delay, that's okay. Medium delay, not okay. Large delay, these are all not okay. I'm not okay. Okay, that's all my singing for tonight. Not okay. Let's map. Delay okay. And I'm getting tired here, so the names of these are kind of failing me. But I'm going to do a lot of the same stuff here. Basically, the aggregation in this plot. But it's going to be with this delay okay, and then the column order is not. And then sort values by okay. It should also be ordered in, we want it to be like okay first, and then not okay. How do you format the delay mapping cell so fast? I don't know. If I was using Vim, I'd probably be faster. Let's also add a title to this. Let's not set title. Okay, so of course I got to put this all together. Font size has to be bigger. Title font size has to be bigger than like your y-axis. Labels. And to be proper about it, set X label should be % total flights it's actually fraction, not a percent. I don't know. Okay, so maybe saying good and bad is better. Right? So this would be like flight result. Is it good or bad? This should be good. Do I have aircraft model in the data? That's a good question. These are all good questions for next time. Let's just as a reminder, point you all towards the data set. I'm going to paste that in here. Oh, and you're going to do it twice because the first one was bad, but aircraft. It doesn't look like we have the aircraft number. What else would it be called? By the way, guys, if you want to vote on this, upvote this data set, that would be fun. All right. So Delta, the best airline in the world. JetBlue, the worst in the world. No, oversimplification, but yeah, that's what we found out today. Yes, we are streaming to YouTube right now. So as soon as this is over, you can rewind and watch it all. You can watch all 30 of my push-ups that I did. But yeah, we're winding down here. It's getting a little late on my end. I had a long day. Got up at like 6-ish. So that's early for me. I want to thank you all for hanging out with me. It's been a blast. I have fun doing these streams. I appreciate feedback, even if it's negative feedback or constructive negative feedback. You know, last stream, someone told me that I was a little bit all over the place. So I try to focus down today and just have one topic and just start with it and to the end. And we worked on flight data and I think had a very productive stream. So I hope you enjoyed it. And I appreciate every single one of you for hanging out. It's so much fun. And I can't wait until we do it again. Definitely had the biggest viewer count on YouTube, but here over on Twitch, which you should be hanging out with us on Twitch if you aren't already, we are going to send over a raid. And what that means is we are going to send all the people currently viewing our stream over to another channel. And I like to usually raid channels that are doing coding. So let's go into the software and game development. I like looking for seeing if people are using Python. Oh wait, I'm the top of the Python. Okay, it looks like someone, I don't know who this person is, Bash Bunny, but she already has 195 people. Maybe I can like raid her channel. Maybe some of them will figure out who I am because of that. We're going to raid right now. Thanks everyone for hanging out, and I will see you next time. I stream Sundays, Tuesdays, and Thursdays. However, that's only subject to if I'm available to stream. So Tuesday I was traveling for work the next day, so I didn't stream. I'm sorry, I can't be that consistent. I have a full-time job and a family and stuff, but when I am around to stream, it would usually be Tuesdays, Thursdays, and Sundays. So, you know, hit that bell notification, all that stuff. Oh yeah, let me also run through some of the last stuff that you guys are all going to leave for, because no one cares about watching, listening to this stuff. But join our Discord, ! Discord. Discord, can I spell? Check me out on Kaggle. Upvote some of my data sets if you think they're helpful. Also, check out my YouTube if you're watching on Twitch. Please give me a subscription or subscribe there, and tell your friends and stuff. Also, we had a competition that we launched on Kaggle, a community competition recently, which was a lot of fun. And we are just going to probably do another one. So that was our third in a series, and we'll probably do another one. Hopefully give away a big prize like we did last time. We gave away a GPU. All right, so we're going to raid the channel. Thanks, everyone, again. See you next time. 10 seconds. Bye, YouTube. Have a good time.